This discussion is about the projection. So we have two vectors. We have a vector u and we have a vector v. And we're going to consider the projection of that vector u onto vector v. So let's consider what that might be. Let's say this is vector v, and this is vector u. We want to construct the projection of u onto v. And the metaphor I like to think about as a shadow. So we envision the sun shining so it casts a shadow that's perpendicular. What we get here is we get this piece right here, and that piece is the projection of u onto v. So we'll recognize then the projection of u onto v is some fraction of the vector v. We want to find out what that fraction is going to be. That's going to be one of our questions. So how do we determine what that is? What's going to be a key idea here? Well, again, we have a right angle here. We have an angle between u and v, which is the same thing as the angle between u and the projection of u onto v. We want to think about how that's going to behave. So what do we remember from previous arguments? Well, the dot product is related to the angle between in the following fashion. So recall u dot v is magnitude of u times the magnitude of v times the cosine of theta. How did we get that? We proved that using the law of cosines and looking at the magnitude of the vector u minus v. So check your notes for that discussion. That's an important fact. But looking at this picture, what do we know here? Looking at this triangle, the cosine is the adjacent over the hypotenuse. So using that fact that the cosine of theta is the adjacent over the hypotenuse, what do we get here? The adjacent is the magnitude of the projection of u onto v. So cosine of theta, the adjacent, the magnitude of the projection of u onto v divided by the hypotenuse here, which is u, or the magnitude of u. So that's our cosine theta. So how can we make sense of this? How can we put this together? So do you see how we can relate these facts? We have this fact, and we have this fact. So with a little bit of substitution, maybe we can come up with something that we can use. So what does that give us? Using this first fact, u dot v is mag u, mag v cos theta, and using the fact that cos theta is the magnitude of the projection of u onto v divided by magnitude of u, how do we put those together? Are we going to make sense of that? So what are we going to say? U dot v is magnitude of u, magnitude of v cosine theta, which we get from previous work. Which of course we're just going to rewrite as magnitude of u, magnitude of v times what? What is cosine theta now? Cosine theta is the magnitude of the projection of u onto v divided by the magnitude of u. Now, this isn't exactly right. Let me just give you a brief caveat here. U dot v could be positive or negative. The way that I have this written here is it's always positive. But in the event u and v are pointing in opposite directions, then the projection of u onto v is going to be in the opposite direction of v. So I don't think you need to be terribly concerned about that, but just recognize that indeed the projection of u onto v could be facing in the other direction. So this u dot v could be a negative value. You'll notice that the u's divide out. So where does that get me? That gets me u dot v equals the magnitude of v times the projection of u onto v. And then, of course, we're going to divide by magnitude of v. So I get u dot v divided by the magnitude of v. again, these are all vectors, is going to equal what? Is going to equal the magnitude of the projection of u onto v. But what the heck is the projection of u onto v? So let's look at this picture. The projection of u onto v is some multiple of the vector v. So let's collect what we know currently. So this is what we have. Again, to clean this up, that really should be absolute value of u dot v, but I'm going to leave the absolute value off because if I preserve the sign, that will actually go ahead and give me the correct answer. So you'll notice the projection of u onto v is in the same direction as v. So the projection of u onto v is some multiple of what? Of the unit vector in the direction of v. What is the unit vector? A vector of length 1. The unit vector would be vector v divided by the magnitude of vector v. So the projection of u onto v is some multiple of that unit vector. But that multiple is going to be its magnitude, right? Because if this has length 1, but I need the length to be that, I need to multiply that u dot v divided by the magnitude of v to get my projection of u onto v. So let's make sure we clarify that concept. The projection of u onto v, looking at the picture, is a multiple of v. But I'm going to come back and I'm going to shrink v down to the unit vector. So thinking of this little vector right here is v divided by the length of v, right there. Now to get the projection, I've got to multiply the magnitude of the projection by that unit vector to go ahead and get the projection vector. So what this will be is this will be the magnitude of the projection of u onto v times the unit vector in the direction of v. Again, really should be absolute value here to be completely honest, but again, I want to keep the sign so that if it points the other direction, I can be okay. So finishing this off then, I get the projection of u onto v is what? Magnitude of u onto v is u dot v over magnitude of v times v over magnitude of v, which is what? Which is u dot v over magnitude of v squared times v. So this is our formula for the projection of u onto v. But you may recall that the magnitude of v squared is really v dot v. So I get the projection of u onto v. Easier to remember it as u dot v over v dot v times v. That's the formula we want to keep in mind in the event we are looking for the projection of u onto v. And again, just to kind of talk about that issue with the negative sign, if this is v and this is u, the projection is over on this side. That's where the negative sign comes in. This would be the projection of u onto v here in the opposite direction of v. So in this case, that would be the projection of u onto v. But again, our rule is the projection of u onto v is u dot v over v dot v times v. That is our key idea.